5.5 kilogram bowling ball moving at 9.0 meters per second collides with a 0.85 kilogram bowling pin, which is scattered at an angle of 85 degrees to the initial direction of the bowling ball and with a speed of 15 meters per second. Part A, calculate the direction of the final velocity of the bowling ball. This angle should be measured the same way theta is. We have conservation of momentum in the x direction, conservation of momentum in the y direction. Our initial conditions tell us that the bowling pin has no initial velocity in either x or y, and the ball has no initial y velocity. When we set these equations up, we can call this one 1. mb times velocity of the ball initially is mb times the final velocity of the ball times cosine of theta ball, plus mb mp final velocity of the pin cosine theta b. In the y direction, we know we have 0 equals mb vb final y plus mp vp final y. We do some algebra and we put in what we know from the initial problem statement. We get the final velocity of the ball times cosine of theta b is 8.798 meters per second. From the other conservation of momentum equation, we apply some algebra here and get final velocity of the ball times sine of theta b is negative 2.309 meters per second. We divide one equation by the other. We get tangent of theta b is negative 0.2624, so theta b is negative 14.703 degrees. Part B, calculate the magnitude of the final velocity of the bowling ball. We can go back to either of our equations before. For example, VB final cosine theta b is 8.798. We put in the theta b we just found, and we get 9.096 meters per second.